Alright, this next video is actually going to be covering two sections. We're going to start with section 7.1 and then we'll shift right into section 7.2. They're very closely related. To start talking about simplifying rational expressions, we should of course talk about what is a rational expression. A rational expression is anything that can be written as a fraction. That's it. That's a simple definition. The textbook has legalese definition, like the small print on a document, or the guy that talks fast at the end of a lease commercial or something that gives you all the legal rules and regulations, and none of that matters. Anything that can be written as a fraction. So 1/8 is a rational expression. 2/5 is a rational expression. Obviously, anything that can be written as a fraction means a fraction is a rational expression. But what not everyone is aware of is x is a rational expression, because you can write x over 1. So anything that can be written as a fraction doesn't necessarily have to be a fraction. If it could be written as a fraction, then it is a rational expression, which leads you to wonder, well, what can't be written as a fraction? Well, a fraction can't have a 0 in the denominator. That's our primary restriction. Fractions can't have zeros in the denominator. Otherwise, just about everything is a rational expression. But of course, since it's anything that can be written as a fraction, we're going to be dealing with fractions quite a bit here. Alrighty, when we evaluate an expression, and we've done this already plenty of times, you plug in the numbers and work them. That's it. A squared plus b squared. If a is 3 and b is 2, then you plug in 3 and 2. So 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. You've done that plenty of times. You're already well established in your skill at that, so we don't need to really talk about that much. Just plug in the numbers in the appropriate places and then see what you get when you work them. Okay. You might want to, you might be able to simplify the expression before you plug the numbers in. Sometimes that makes things easier, but that's a preference. That's a personal preference. That's up to you. Okay. Undefined expressions, this is the restriction I was talking about. When the denominator equals 0, you're going to have an undefined expression. It's not rational. It's undefined. You cannot have a 0 in the denominator. So we're looking for situations where there is a 0 in the denominator so that we can say, no, we can't have that. It's kind of like an allergist. Somebody comes in and says, I have trouble when I eat. I have all kinds of physical problems when I eat. And so what they'll do is they'll test you to find out what you're allergic to and then tell you don't eat those things. This is a very similar thing that we're going to do here. We're going to find out when will there be a 0 in the denominator, and then we're going to say don't be in a situation, don't be in those situations. For example, let's switch over here to my paint program. We haven't done this for a while. If we had the situation, I believe I did it like this. Yeah. Let's say we had x over x plus 3. Okay. This is a rational expression, as it is. But we need to make sure we never have a 0 in the denominator, because that would be undefined. So what we do is we take the denominator and we work it as if it was its own equation, and we find out when will x plus 3 equals 0. Well, it's pretty easy to see that x plus 3 will equal 0 when x is negative 3. So what we want to do is we want to say that x over x plus 3 is a rational expression, except when x is negative 3. So we want to say x cannot equal negative 3, and the equal sign with the line through it means not equal to. Okay. That's all we're doing on sections like that. Just take, when they're asking what numbers cannot be used for x, what values cannot be used for x, take the denominator, set it equal to 0, solve it, and then say x cannot be that number. Because if x is ever that number, there'll be a 0 in the denominator. Can x be 0 in this case? Absolutely. 0 plus 3 would be 3. You can have a denominator of 3. It's okay to have a 0 in the numerator. There's nothing wrong with that. So 0 over 3 would be a rational expression. That's fine. There's nothing wrong with that. You just can't have a 0 in the denominator, and it's not talking about you can't have 0 as x. It's talking about you can't have a total be 0. So x plus 3 cannot be 0. X can be 0, but not the quantity. Okay? All right, let's pop back over here. Excuse me. All right, simplifying expressions. Remember, expressions can be simplified, equations can be solved. So all we're doing is simplifying. We're not going to have x equals 5 or anything like that. These are just expressions. So make sure that, you know, if you're doing your work, if you ever end up with a solution, an answer, that's wrong, because all you can do here is simplify. Okay. When you simplify an expression, here's your process. Factor the numerator, factor the denominator. Remember that we're dealing with anything that can be written as a fraction, so you're going to have fractions involved. Factor the numerator, factor the denominator, and then cancel out the common factors. And I have factors repeated several times because you may need to make sure you're only canceling factors. Let's go ahead and take a look at that over here on the Paint program. Oh, here it is. Okay. Get a new screen. No, I don't need to save it. Okay. Let's say we have the rational expression x squared plus x over x squared minus 1. Okay? Our process says to factor the numerator. So if we looking just at the numerator here, we have a common x. And this is exactly how I do it when I do my work on my paper. I just factor it right above, right like that. Okay, and then I cross that out to show that I'm done with that. Then it says to factor the denominator. The denominator here, we might recognize a difference of squares. So it's going to be the roots with the same function and then the opposite function. Okay. And now I'm done with that. I factored that, so I'm done with that. Okay. Then it says to cancel out the common factors. Factors, 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 factors. Only common factors. So let's look and identify the factors here. The x is a factor, and the quantity x plus 1 is a factor. Quantity x minus 1 is a factor, and quantity x plus 1 is a factor. Factors are things that are being multiplied, and multiplication is what's happening in here between the parentheses. Right? Whenever you have something in front of parentheses, it means you're multiplying. So this is multiplication here, so that means these are factors. This is multiplication, so these are factors. And we can cancel out common factors. If they're exactly the same on numerator and denominator, we can cancel them, and that will just cross them out. And so then your answer is whatever's left. X over x minus 1. Now here's the problem that comes up a lot. A lot of people will look at this and say, oh, well, here's an x and here's an x, numerator and denominator, so I should be able to cancel those, but you cannot. And the reason you can't cancel those is because this x is not a factor. This x is having a 1 subtracted from it. Remember, factors are only for multiplication. Subtraction does not have factors. Okay? So this x is not a factor, therefore this x cannot be canceled. If the whole quantity is a factor, then you cancel the whole quantity, but part of a quantity cannot be canceled. Okay? Only factors can be canceled. Alright? That's your procedure right there, is just factor the numerator, factor the denominator, cancel common factors. And then whatever is left over is your answers. You're done. Okay? No matter how big and nasty and complicated it may look like it's getting, that's it. That's all you're doing. Factor the numerator, factor the denominator, cancel out common factors.